Alright, welcome. Here's the next video. We're going to discuss relations. You're expected to understand this one, and then there will be another video, probably sometime this weekend, to go over functions, which we hopefully will be able to review on Tuesday. So, let's look. What am I hoping to do here? I want you to be able to determine the domain and range, a reasonable domain and range, for real-world situations. This is the ITEAX objective, which means this is star testable type objective, and this is what I should be saying. I'm trying to make sure that these are the things that we go over. Some subtopics within this is we want to be able to represent relations and interpret graphs of relations. So you've got this to kind of consider, and there you go. So let's look at the first thing we need to look at. Let's look at some vocabulary. So here's all the vocabulary for this. We have the coordinate system, coordinate plane, x and y axis, origin, ordered pair, x and y coordinates, relation, mapping, domain, range, independent and dependent variable. All these are interrelated. Here you go. This is what we should know. These are things that you should have already been introduced to in middle school. So, first thing I want to look at is this example. Express the relation 4, 3, -2, -1, 2, -4, and 0, -4 as a table, graph, and a mapping. Okay, so we need to identify the x and y, and so you need to make sure that you understand what is the x and the y in each one of these. So you know x, y, x, y. These are all ordered pairs, x, y. Okay, ordered pairs are, say, groupings of x's and y's together. Now, the table would just have us set up a table with the x in the right, left, and the y in the right. So x is on the left, y is on the right. And you can see here, basically I'm just taking the points, writing them out, and there we go. Now we've got the graph, and on the graph I'm just plotting the different points. There's our x-axis, there's our y-axis, there's the origin. Keep in mind again, x is positive over here, x is negative over here, y is positive up here, y is negative down here. So, like to graph 4, 3, I went to the right 4, but up 3, that's where I got that point. -2, -1 went to the left 2, and then down 1, and that's -2, -1. A mapping is put a bubble, make some bubbles. You got an x and y. You put your x's, all your unique x's, all your unique y's, which means you don't write them if they repeat. Just write them once. Then you draw a line connecting the x to the y that goes with it. So you can see here, like -2, 2, -4, and 0, -4. The 2 and the 0 both went to -4. I didn't have to write it twice. So kind of keep that in mind. Mappings should be easy. So let's look at another example. I guess before I do that, I need to remember that I need to talk about the domain and range. So domain and range, same points. Domain is your x values, and it's the set of all your x values, and range is the set of all your y values. So your domain is 4, -2, 2, and 0. Your range is all those y's, so that would be 3, -1, and -4. I don't have to write -4 twice because when it repeats, you only have to write it once. Okay? So x values is your domain, y values is your range. Now the second example. So same thing, table, graph, and mapping. Alright, so we're going to say 3, -2, 4, 6, 5, 2, and -1, 3. There's the table. You can see all I'm doing is writing the points and separating the x's and the y's. There's the graph, which you should know how to do. 4 points. And then there's the mapping. Notice how I have a line going to each one, and since there was 4 different x's and 4 different y's, I just drew it like that. Sometimes you see in mappings where they'll put them in order, like from lowest to highest. I'm not too worried about that. I'm just more worried about you putting the numbers in there correctly. Do you realize that this is a -2 up here on the top on the y mapping? Okay, so and then the domain and range here for those, and it would be 3, 4, 5, and -1, and the range was -2, 6, 2, and 3. Okay, and that's just basically what you saw in order. Let's see, in order like that. Okay, so that covers some basic bits about relations. Realize that a relation is just like a set of points, a group of points. We'll talk about what's the difference between a relation and a function later. But a relation is the most basic thing. It is a group of points. All right. So let's talk about independent and dependent variables. Independent, everything. So now we're going to start looking at things having two things, like two variables. And one is related to the other, or one is influenced by the other. So in this example, what we're going to do is we're going to see some word problems, and we're going to decide who is the who influences who's the boss over who will force the other one to change, not the other way around. Okay. So what we have here is an example. In warm climates, the average amount of electricity used rises as the daily temperature increases and falls as the average temperature decreases. Identify the independent and dependent variable. It should get there soon. There we go. All right, so we'll discuss that and what does it mean to be independent and dependent. Again, who is going to force a change to the other? You know, does the electricity force a change to the temperature, the electricity used, or does the temperature force us to change how we use the electricity? That's what you got to figure out. All right, so I had to take a little bit of a break between classes, but here we've got this word problem, and we want to discuss this independent and dependent, which I had talked about before. So we're looking at this. Does the electricity depend on the temperature, or does the temperature depend on electricity? Now think about it. Who is kind of influencing here? And so if you can kind of answer this little statement, blank depends on blank, wherever you put in the first blank would be your dependent variable, and the second one would be your independent. So does it make sense to say the temperature depends on the electricity, so that somehow the electricity is changing our temperature? Or does it make sense to say the electricity usage depends on the temperature? So like when it's hotter outside, I have to use more electricity, that type of thing. Obviously, it would make more sense to say electricity usage depends on the temperature outside. So then electricity usage is your dependent variable, temperature is your independent variable. So that one, not too bad, fairly simple. Okay, so let's look at this one. The number of minutes, number of calories you burn increases as the number of minutes that you walk increases. So again, what makes more sense? Does it make sense to say that the number of calories depends on the number of calories you burn depends on the amount of time you walk, the minutes you walk? Or does it make more sense to say that the minutes you walk depends on the number of calories you burn? Okay, keep in mind, very specific in the phrasing here. So yeah, it would make more sense to say that the calories that you burn depend upon how many minutes you walk. And notice how it's even written that way. So we're saying here our independent is the minutes walking, and the dependent is the number of calories burned. Okay, that little symbol right there is numbered, not hashtag. For all you little Twitter freaks. Okay. Then the next thing we want to be able to do is write graphic descriptions. So here's one here. Write a graphic description of the graph of Macy's. Write a description of the graph of Macy's speed as she swims laps in a pool. Okay, so notice here we've got speed, we've got time. And if you look at this, you're looking at what happens here. Okay, so look, like this is going up, her speed is going up, then it goes down. And you've got to realize this right here, when you get to that line, means like you came to a stop. So we could say something like her speed increases as she swims the lap. It does decrease as she gets to the wall, because that's what would happen. You're not going to swim through a wall. And then when she gets to the wall, she has to stop and turn, right? So she stops and turns, and that would be this point right here is where she's stopping and turning before she goes again. Okay, so this stopping is these points right here. You can see the decreases and you can see the increases. So you got to try to make sure that you're very descriptive with your wording. Okay, here's another one. Write a description. Here I'm not giving you anything other than you've got a graph about a bike ride, you know, the distance and the time. Keep in mind, time is going forward. It increases as we go from left to right. So then the question is the distance increasing as you go up from bottom to the top. So we can say here the amount of distance is increasing. The distance that they travel on the bike is increasing because this is increasing right here at a constant rate, because this is a straight line right here. This is a straight line. We say that's at a constant rate, which means you're going the same speed. Then we stopped because we're not going any more distance for a while, and then they started up again and went again at a constant speed. They started biking again. So that's all you need to say there. It does seem like a lot, but you're saying that they went at a same speed, stopped, and then went and left again. All right, the last one, my last example. Okay, here's another one, change in income. Maybe pause this and tell me what you think it should be. So pause for a second, write out what you think, and then compare it to my answer. This one I kept simple. I just said the change in the income is increasing as time goes up, or as time increases, the income increases. I did make note there is a slight change at one point where it does look like they get a little bit of an extra bump right there. And so there was a time when the increase was different for the income. It looked like they got a little bit more. All right. So that's about it. If you do have questions, feel free to ask. Make sure to let me know on Tuesday, or you can let me know through Edmodo, and I will do my best to check Edmodo as often as I can. That's it. Thank you very much.